Now, when we run the game, we can see it runs just fine with no crashes, but on our Kali machine, we can see a request was made to retrieve the reverse shell executable, which gave us a reverse shell on the machine. Let me show you how easy it is for hackers or crackers to own your machine with pirated video games. So I have this pirated version of Rocket League here, nothing fancy with it. Typically, prior to installing any pirated version of any game, the group or the individual who pirated the game will ask you to disable your antivirus or exclude the game folder from Windows Defender, because the modified executable or the DLLs, quote unquote the crack, may contain segments of code that any antivirus may flag as malicious. Well, actually things can get worse than that. Let me show you how. We're going to implement a simple DLL proxying attack. The idea of this attack is that when a game is executed, it loads some DLLs related to it into memory. A DLL proxying attack happens when we place a malicious DLL between the game and the actual DLL. This attack is called DLL proxying, not DLL hijacking. In DLL hijacking, we do not forward anything from the game to the actual DLL back and forth. We just hijack the DLL callback and we do not care about what happens to the game if it crashes or not. So the very first thing we need to do is to choose a DLL to proxy. Let's go with this Steam API DLL. Next, we need to extract all the functions or the APIs exported by this DLL. This can be done easily using this simple Python script. Here we use the PE file module to get a handle to the DLL, and then we loop through the functions in the exports table and write them to a file called exports.txt. The next thing we need to do once we have all the function names is to place them in the malicious DLL. So now, using Visual Studio, we create a new DLL project. But before we proceed, we first need to copy the Steam API DLL into the project folder and rename it to any other seemingly legit name, and I'll tell you why in a sec. Let's rename it to rlassets.dll for example. Now, in order to proxy all the functions from our malicious DLL to the legit DLL, we need to provide a preprocessor directive for each function to the compiler. Basically, this line here tells the linker to export this function from our malicious DLL to the legit DLL. We need to provide this directive for each function in a DLL, so we save ourselves the trouble and modify our Python script here with this line. And once we have all the directives we need, we copy them into our malicious DLL here. Just don't forget to include the legit DLL in the project folder so that the linker can find all of these exported functions during compilation. Now the last thing we need to do is to implement the actual malicious code that will be executed when the game runs. I made a video a while ago about DLL injection, in which we went through what a DLL is in the first place and what these callbacks do and much more. So check it out if you want to learn more about DLL internals. But essentially, these callbacks run when certain events occur. For example, the DLL process attach callback is triggered when the DLL is loaded into the process memory. The DLL process detach callback is triggered when the DLL is unloaded from the process memory, and so on. Since we want the malicious code to be executed when the game runs, we need to use the DLL process attach callback. Here we call the hack function that has the malicious code. And this function will first define a partial command that downloads a reverse shell from our Kali machine and sets it as a hidden file. So in Kali here, we generate a simple reverse shell using MSF console, and then we set up a simple HTTP server using Python on port quad 8, and we use nickcat to set up a listener to wait for the reverse shell to return. So back in the code here, we create a process to run this PowerShell command and wait for it to finish. Then we create another process that will execute the downloaded file and give us a reverse shell. Now, after the DLL is built, we make sure to replace its name with the legit DLL name, and also make sure the name of the legit DLL matches the ones in the compiler directives, or the build will fail. Now copy both of these DLLs in the game folder. Now, when we run the game, we can see it runs just fine with no crashes, but on our Kali machine we can see a request was made to retrieve the reverse shell executable, which gave us a reverse shell on the machine. From here, a threat actor can do whatever they want. They can go for privilege escalation, place an implant, drop a ransomware, or even place some persistence techniques. The sky is the limit here. This was just a simple DLL proxying technique. Nothing fancy. We can go for something else completely different and stealthier, such as packing a dedicated malware inside the game executable itself. This is why you can trust crack posted by some individuals on underground Steam forums. I know that some people will say, I only download pirated games to try them before purchase, and I get these cracks from trusted groups or individuals, etc. Well, let me show you something. This is a game called Watch Dogs Legion. This game was cracked by a cracker codenamed Empress. They claimed that this game had Denuvo V10, VM Protect v3.5, Uplay, BattleEye, file integrity protection, and a custom protection on the top of all of that. Do you think someone with this set of skills cannot come up with a simple malware that can bypass Windows Defender or some sort of an AV solution? You might want to think about this again. I am not claiming that they put any malicious code inside the cracks. I do not know that. I did not reverse engineer this game, neither that I will. I'm just saying that when something takes that much effort to achieve and then it's given away for free like that, it's just too good to be true.